Now applications of thermal effect of current. Applications of thermal effect or heating effect of current. Number one, bulb is there. 2, heater. 3, geyser. 4, electric furnace, you can say. 5th, welding, electric welding, you have heard. What they do? That time they join or keep the two rods, the metal rods, very close to each other. One is connected to the negative terminal of the source, the battery, and the second one is connected with that, the welding rod. He just puts the welding rod between these two after touching them. So a large current goes through it, and due to I square RT, so much heat is generated that the welding rod gets melted and the gap is filled with the molten material and they get joined together. Then one more and very good servant of your in the house, in every house it is a very good servant, and that is the fuse. That is the fuse. And what are the properties of that fuse wire? The fuse wire is made of an alloy of tin and lead, and its resistance is very low and melting point, its resistance is very high. The fuse wire is made of an alloy of tin and lead, which has very high resistance or resistivity and very low melting point. Whenever in the household electric circuit some fault arises, due to which, or short circuiting you can say, due to which a large current flows through the circuit, and since the large current is flowing from this, so the more heat is generated, and since its temperature melting point is very low, so it gets instantly gets melt, and the connection is disconnected, due to which the household circuit is saved by the, इसकी अपनी कुर्बानी दे दी उसने. तो ये कहते हैं इसीलिए बहुत बढ़िया आपका सेवक है ये, जो अपने आप को कुर्बान कर देता है आपकी सेफ्टी के लिए. Similarly, there are a bulb. This bulb is connected with the series with the electric circuit in the house. Very high heat is generated over here, but same current is passing through this wire and this. Why they don't get heated? So it is because of its power rating, because of its resistance. Here the electric lines has very low resistance due to its resistivity, that is copper, and the bulb filament has very high resistance, due to which very high heat is generated and then it becomes white and bright, whereas there is no sufficient or enough heat generated to heat it up. So that's why the lines do not get heated and the bulb gets very hot and converts this heat into light. So other things you can also read and go through it. If you don't find any topic in your book and you find a problem, then write in comment box. I will try to solve your problem. चैनल को सब्सक्राइब नहीं किया है तो जरूर करें, और व्हाट्सएप नंबर उसमें दिए हुए हैं, अगर आप ध्यान से देखें डिस्क्रिप्शन बॉक्स में, तो यू कैन व्हाट्सएप ऑल्सो टू गेट योर क्वेरीज क्लियर. These are the theory. Theory will get cleared when you will do some numericals. So practice numericals on each and every topic. I am also giving you numericals, but it is not possible that I'll get plenty of numericals on these videos. So you go through the numericals, you try to solve your numericals, and if you find some problem in solving certain numericals, even you write down in comment box that numerical question, I'll give you the solution of that also. Let us try to solve a problem. An electric kettle has two coils. When one coil is connected and switched on, it takes 12 minutes to boil water. And when the same water is taken and the second coil only is switched on, then it takes 24 minutes to boil the water. Now, how long will it take to boil the same water when both the coils are connected in series? So, as far as the heat required to boil the water is V square by R into T. We have already studied that the voltage is known to you, then resistance is known to you, and time is there. Let us take T. So heat produced is V square by R T. So for the first coil, it is V square by R 1 T 1, and for the second coil, Q2 equals to V square by R2 and T2. This V is same source, that's why. And the water is also same, so Q1 and Q2 will be equal. That means we have V square by R1 T1 equals to V square by T2 R2. That simply gives you T1 by R1 equals to T2 by R2. That means R1 upon R2 will be equals to T1 upon T2, that is 12 by 24, that is 1 by 2. So here we get the relation that R2 is equals to twice R1. Now they are connected in series. When they are connected in series, then R is equals to R1 plus R2, that is equal to 3R1, we can say. This 2R1 plus R1 is 3R1. So in that case, the heat generated will be, same source is there, the time we have to find, and we have the resistance 3R1, this much, and this heat is same as that of the Q1 as well as the Q2, so we can relate with this Q1. So here we have Q1 is equal to Q, that means V square by R1 T1 equals to V square by T into 3R1. R1 get cancelled, V square get cancelled, so we get T1 equals to T by 3. That means T is equal to 3T1. That is 3 into 12. That is 36 minutes. So when you connect them in series, then it will take 36 minutes because the resistance is large and the heat generated is inversely proportional to the resistance. It is not I square R, it is V square by R. So the student get confused where the is to be taken I square R and where is to be taken V square by R. So in case of series, when the current is same, you can say I square R in different places in which the heat will be generated more. So for that case, not in this case. So here I'll just repeat, the heat generated is equal to V square by R into T. In first coil, V square R1 into T1. So this is the heat generated by the first coil, and the second coil is V square R upon R2 into T2. Since the same water is being boiled, so this Q1 is equal to Q2. So here we can have V square T1 upon R1 is equal to V square T2 upon R2. That gives you T1 by R1 equals to T2 by R2. So R1 by R2 will equal to T1 by T2. That is 12 by 24. That is half. That means R2 equals to 2 R1. Now when they are connected in series, R equals to R1 plus R2. That R2 is 2 R1. So R1 plus 2 R1 is 3 R1. And the heat generated will be V square into T upon the resistance, that is 3 R1. And again this heat, the same water is being boiled. So this Q1, Q2 and Q all are same. So we can equate with either of this or that. So it is better to with the R1 because it is in terms of the R1. So V square T1 upon R1, this equals to V square T upon 3 R1. So R1 gets cancelled, V square gets cancelled. So you get T1 equals to T by 3. So T equals to 3 T1. So that T1 was 12 minutes. So this is 12 into 3, that is 36 minutes. So it will take 36 minutes. So likewise you solve the problems, and if you still find problem or face difficulty, you may write in comment box. Even you can write the whole question. I'll try to solve it. Thank you.